Yeah. All right. Hey, I'm here with my friend Keen, who I haven't seen in a while, actually since China.
China, 2011 or 12, something like that in China, yeah.
And lo and behold, he shows up here, and he's got a startup.
Yeah.
They've just launched their public offering today, so we're going to take a look at it. And so here goes.
Hi. Yep, like Dave was saying, my name's Keen. My company's name is Bonsai, and we're releasing our platform today over here, which is pretty cool. Our goal is really to enable any programmer, regardless of their ML or AI expertise, to be able to put AI into their application. And the way we do that is kind of cool. We have this new programming language, this new special purpose language, scripting language called Inkling. And Inkling is kind of different than all the other frameworks that are out there. You don't have to worry so much about the details of the layers you want in your neural network and its parameters. Instead, it's more around describing what you want the computer to learn and how you plan to teach it.
Okay. And so as a developer, how do I actually get started and use this thing?
So it's a platform as a service, so it's kind of like Heroku. You come to our website, bons.ai, and you can download the tools. There's a command line tool. You write your little Inkling script and you upload it. And once you upload that script, the machine, our AI engine will build a model for you, and then it's exposed as an HTTP API endpoint. So with that web endpoint, you can then just push data up to the server and get back a prediction.
That's awesome. And so, as we were talking about earlier, I remember the early days of Heroku when you had to kind of do everything in their system, and it was all kind of done for you, which was awesome because as a developer, I didn't have to worry about handling all those complexities.
That's right.
But I had to get my code in there somehow.
That's right.
And today, how do I get my code actually into your system?
Yeah, so we have a Bonsai command line tool, and you'd say we call the AI models, we call them brains, and so you create a new brain on the website, and then with the command line tool, you say Bonsai brain load. And then the code you need to load into that brain. And then you say Bonsai brain train, and it kicks off a training process.
So it just pushes the code up there, and then it's working.
That's
and then you train it.
And then you train it.
Right.
And there's, if you go to the web page for the brain, it'll say like, okay, here's my accuracy, and it'll give you an indication of where it's at in terms of training status and how much longer you need to wait before it's trained.
Okay.
And then when it's done, it says I'm done, and it gives you the example code snippet you need to drop into your application.
Okay, good.
To take advantage of it.
And then you're off and running.
You're off and running. Yeah, hopefully.
With artificial intelligence in your app.
Yeah, it's very cool. Yeah.
Nice job. Well, congratulations, and let's take a look at it in a few minutes to get a little more detail on actually seeing how it works.
Yeah, that'd be great.
Here we are. We're at the first O'Reilly Artificial Intelligence Conference here in New York City, and this is my first interview as part of Intel. So we'll probably have some more, and I'll get better at it as we go. I'll machine learn myself.
Yeah, that's right. Train your neural network.
Get better as we go. Yeah, great. Thanks.
Pretty interesting. So first you need to give it some types, because the system needs to know what types are the input, what type is the input, as well as what type is the output from the neural network. So that's the first part, is declaring some schemas. After that, you need to give it a way to think about the problem, a conceptual model. So for this particular problem, for landing the lunar lander, I'm telling it, I want you first to learn how to say stable, and then how to go to the center, to be in between the flags, and then I want you to learn how to land. Once I give it those concepts, I need to give it what we call a curriculum, some way to learn that. And so in this particular code, we basically say, okay, to say stable, I want you to use this simulation, the lunar lander simulation. I want to configure these parameters, and I want you to maximize an objective, a stabilized objective. That objective is written inside the simulation. It's a function you write basically to measure how well the system is doing. When you write this code, you feed that to our server, and then our AI engine goes through the process of generating models for this problem. The way it knows which models to pick is through a combination of heuristics and some other really cool stuff, where we're keeping track of all the code that's been submitted and all the best models for the code that we've ever come across. Once a model is created, the system begins to train.
So do you use like open source code libraries, or do you?
We do. So underneath the hood is TensorFlow, but the way the system is set up is a bit like a compiler. This code goes up to our servers. There's a middle part where we decide what deep learning topology we want, and then there's a back end that outputs that as a TensorFlow model.
How do I deploy this online as my web app?
So once the model is trained, and even actually while it's training, you can access it through our HTTP API. So there's a REST endpoint. You basically just push data to that endpoint, and it'll give you back a response. And that works in a classical REST style. But we also have a WebSockets-based mode that's good for working with more real-time applications. Right now, we've wrapped that API with a Python library and a C++ library. And we'll wrap it with more libraries to make it easier to work for more and more languages.
Very much like GraphLab, where you can now have the code, but then you call their API on your web app, and then they call theirs, and they can do that.
That's right. That's right. It's like that part of GraphLab, yes.